Stargazers and cosmologists are stunned by the approaching vanishing of the North Star, Polaris. This occasion is expected to be the next big thing in the universe of astronomy. Yes, you heard that right, Polaris is going to be scoured off our stargazing map for good. And this looming heavenly disturbance conveys significant ramifications for our ground-based telescopes, which use it as a reference point for their alignment and precision. Brian Cox warns that Polaris blast is upcoming and will change the night sky forever. Let's dig more deeply into the narrative of the North Star and why its end matters so much. For centuries, Polaris has been a heavenly guide for both stargazers and navigators. However, all of this might change in mere decades if not years. A late research work presented to the esteemed Royal Galactic Society in September 2023 has essentially sealed the fate of this guiding light. Polaris is on the edge of a destructive event, an explosion that could result in its vanishing from the night sky for eternity, changing our astronomical compass. Yet, before we dive into the likely results of this discovery, let's take a look at the star in question, also known as the North Star or Pole Star. Polaris holds a unique position in our night sky due to its proximity to the celestial North Pole. It sits directly above Earth's North Pole, giving the illusion of being almost fixed in the northern sky. Situated in the Ursa Major constellation, which is also known as the Big Dipper or the Great Bear, Polaris shines as a moderately bright yellow-white supergiant star. It eclipses the Sun in brilliance, emitting significantly brighter light across the vast cosmos. In terms of sheer size, it dwarfs our Sun, boasting a radius estimated to be multiple times larger. Regardless of its apparent peculiarity, Polaris is part of a complex triple star system. Two of these stars, Polaris AA and Polaris EB, appear as a single star to the naked eye. A third companion, called Polaris B, orbits this binary pair. The complex gravitational interactions among these stars influence their orbits and brightness, causing irregular variations in the star's brightness and pulsation patterns. However, the exact mechanisms behind these interactions remain a significant mystery. On top of all this, the dramatic distance of Polaris from our planet adds a fascinating temporal twist to our understanding. Since it is 323 light-years away from us, the light we see from Polaris today embarked on its interstellar journey north of 3 centuries ago. If we were to witness Polaris explode right now, it would have actually done so many centuries ago. The Earth a long time ago was very different. In the mid-18th century, humanity was navigating through a period marked by significant historical events and cultural shifts. It was a period at the end of the Renaissance period, the beginning of the Enlightenment, and the dawn of the Industrial Revolution. In several areas of the planet, scientific advancements were gaining speed, with figures like Isaac Newton forever changing the scientific landscape. In terms of daily life, society was still largely agrarian, with farming being the primary occupation for most people. Urbanization was gradually increasing, leading to the growth of cities and the expansion of trade and commerce. Culturally, Baroque music and art were gaining prominence. So if Polaris explodes tomorrow, it would have indeed done so when Earth was in the midst of a period of exploration and transformation, setting the stage for the advancements that would shape the centuries to come, just as this event would change things for our future. Throughout the centuries, the North Star has wound around its significance through the tapestry of civilizations across the ages. This heavenly signal served as a guiding light for ancient mariners and explorers, illuminating their paths across vast seas and uncharted territories. Polaris has been a reliable reference point guiding explorers in the Northern Hemisphere, enabling them to chart courses with confidence. Polaris has embodied a cultural and navigational cornerstone for centuries and shaped the story of ancient explorers, storytellers, and scientists alike. So how do we know that the star is approaching its end? Designated as a Cepheid variable star, Polaris has distinct properties and periodic variations in brightness. Its predicted brightness changes have been instrumental in unraveling mysteries about variable stars and aligning cosmic instruments. These rhythmic pulsations have generally followed a predictable pattern, helping astronomers predict its behavior with relative ease. However, in a recent research paper, researchers revealed a deviation from this usual pulsation cycle that has begun to puzzle the galactic community. Polaris has taken on an irregular, erratic rhythm of dimming and brightening, This anomaly has prompted intense scrutiny among astronomers, striving to understand this cosmic oddity. This departure from its norm has sparked concerns among scientists, suggesting that Polaris may indeed be approaching the twilight of its existence. Polaris' pulsation period has recently begun to elongate. The star was previously stable in its cyclic brightness shape, but now cosmologists have observed a slow lengthening of the pulsation period, with an annual increase of 4.5 seconds. While seemingly minute, this change holds significant astronomical importance, indicating a departure from its established behavior. There have been several theories about this situation. Some attribute this shift to gravitational interactions within the Polaris star system. These interactions could be altering the star's atmospheric conditions, thereby influencing its pulsation patterns or, more specifically, how we perceive them. However, opposing voices among established researchers suggest a far more alarming possibility. The star is dying. Whether it's a result of gravitational transfer or a harbinger of an impending celestial explosion, the abnormalities in Polaris behavior have ushered in a new era of astronomy. One way or another, set to change everything we thought we knew about triple star systems like Polaris. Speaking of how discoveries change our perspective, it was in 2006 that we got a close look at Polaris courtesy of the Hubble Space Telescope. Astronomers also unveiled the elusive companion star nestled so closely next to Polaris that it had been difficult to detect it previously. This was the very first image of our heavenly neighbor capturing its bright light. Today, we know that the companion Polaris B orbits the central pair at a distance of approximately 2 billion miles. Although astronomers had inferred its existence from light observations of the triple star system nearly a century ago, its faintness compared to Polaris hindered direct observation until the Hubble Space Telescope made it possible. This all began with the launch of the Hubble Space Telescope, HST, in 1990. Its deployment opened a window to the universe, providing unprecedented clarity and redefining our understanding of astronomy. The HST captured cosmic marvels that reshaped our fundamental understanding of space. Among its iconic achievements stands the stunning image known as the Pillars of Creation in the Eagle Nebula, which houses giant columns of gas and dust where stars are born. Another milestone moment came with the discovery of the Hubble Deep Field, an apparently empty patch of space that upon closer inspection was teeming with thousands of galaxies. This single image expanded our view of the universe's sheer vastness and complexity forever. The HST also studied exoplanetary atmospheres and revealed tantalizing clues about their composition. The presence of elements like water and organic molecules in these distant realms hints at the tantalizing potential for habitability beyond our solar system. Building upon the legacy of Hubble, its successor, the James Webb Space Telescope, JWST, was launched to push the boundaries of technological advancement further. Drawing lessons from Hubble's achievements, the JWST stands poised to propel us deeper into the mysteries of the universe, continuing the tradition of exploration and discovery begun by its esteemed predecessor. One of the JWST's standout features is its unparalleled ability to capture cosmic vistas with stunning clarity, banishing the dark shadows that once obscured our grand observations. The telescope operates primarily within the infrared spectrum, penetrating through cosmic dust clouds and revealing celestial treasures previously hidden from human sight. At its core lies a massive 6.5-meter primary mirror composed of 18 hexagonal segments, surpassing Hubble's mirror in sheer size and sophistication. This groundbreaking telescope has heralded a new era of astronomical exploration, poised not just to uncover the distant reaches of the universe, but also to unravel the mysteries of our cosmic past. With its unique capabilities and extraordinary vantage point in space, the James Webb Space Telescope stands as a beacon of human ingenuity, unlocking the secrets concealed within the celestial tapestry. So far, we know for certain that there are intriguing parallels between Polaris and Betelgeuse. Both of these giants are said to approach their ends. Betelgeuse is a prominent star in the Orion constellation and has exhibited perplexing anomalies in its brightness, much like what we observed in Polaris. This similarity has spurred the astronomical community to monitor both stars closely, aiming to untangle the cosmic puzzle that binds them together. Now, as we embark on this extraordinary journey into the vast unknown, the implications drawn from Polaris hold particular significance. It serves as a testament to the ever-changing nature of our universe, where cosmic anomalies transcend the boundaries of existence. Located approximately 430 light-years away from Earth at the second Lagrange point, or L2, the JWST agilely trails Earth's orbit around the Sun. From there, it provides us with an unobstructed and vigilant eye into the vast cosmos. Yet, the journey into the universe is not just a journey across light-years. It's a journey through time itself. The JWST uses state-of-the-art infrared instruments capable of peering back billions of years into the past, capturing the ancient light emitted by celestial objects as the universe expands. This light undergoes a transformation known as redshift, shifting from its original visible spectrum to the infrared frequency or longer. The JWST is perfectly suited for detecting and interpreting these infrared signals from distant